So hopefully you all have enjoyed the section 1, which was on types of motion and the reference frame. Now enjoy the segment 2, which is about the physical quantities, scalars versus vectors. So now we are going to study about the physical quantities and the difference between scalar and vector quantities. So as you can see on the screen, scalar quantities are the one which has only magnitude and no direction. Examples like temperature, density, speed, energy, power, volume, time, distance, etc. Scalar quantities can be represented by using a number followed by an appropriate unit. And the operations like addition, subtraction, multiplication and divisions are all applicable to scalar quantities. The properties of scalar quantities are it has got only magnitude and no direction, and they obey commutative and associative laws during algebraic operations. Okay, so commutative laws are like a plus b will be equal to b plus a. Also, a dot b will be equals to b dot a in case of scalars. And the associative law is like a dot b plus c will be equal to ab plus ac. Okay, and if we have a into b into c, it can be written as ab and then multiplied by c. So basically these two operations are allowed in scalar quantities because they behave just like a normal number. Now coming to vector quantities, in vector quantities, as you can see, there are two things that are important. It has got a magnitude as well as a direction. Examples are displacement, velocity, acceleration, force, momentum, etc. Now representation of vectors. So vectors can be represented in two basic ways. First one is by using directed line segment. There has to be a line segment whose length will be equal to the magnitude of the vector and the direction in which the line is pointed. That gives the direction of the vector. So if we have this as the directed line segment, it shows the length of this line segment is equal to the magnitude of the vector. And if we have some definite direction like an axis, if we consider an x-axis in this direction, then the angle that this vector makes with x-axis, that gives the direction of this vector. This is one way of representing a vector. Another way of representing a vector is through unit orthogonal vectors. Okay, so unit orthogonal vectors, or by drawing it in form of a directed line segment. Now two vectors can be multiplied in two different ways. Okay, the multiplication will be different, and the addition and subtraction properties are also different from the normal scalars. So coming to the properties of vectors, it has got both magnitude and direction. Okay, the magnitude is represented by basically a value followed by some unit, and the direction is represented with the help of a directed line segment or by using the unit orthogonal vectors. Now the direction can be also represented in language. Now in addition and subtraction, the addition and subtraction is not very similar, because if we are adding say 5 meter per second velocity with 3 meter per second velocity, result is not always going to be 8 meter per second. It will be 8 meter per second if the velocities are in the same directions. But if the velocities are in different directions, say one velocity is towards east and the other velocity is towards south, okay, now if we add them, the result is neither going to be along east or going to be along south, and their result, the magnitude, will also be not equal to the sum of their magnitudes. So in that case, we have got some special laws with which vectors who has both magnitude and direction, their addition and subtractions can be carried out. So if we have two vectors and we need to add them or subtract them, we can use triangle law or parallelogram law of vector addition. If we have got more than two vectors, we can use polygon law of vector addition, but that has to be done graphically. A much better and simpler solution is by adding the resolution of the vectors, okay, by adding the components of the vectors by using the unit orthogonal vectors again. So we will study these things in great detail in the next segments of the chapter. Now coming back to the multiplication of vectors. So when we are multiplying a vector, there are basically three kinds of multiplication in a vector. A vector can be multiplied with a scalar. So a vector can be multiplied with a scalar, and the result is going to be a vector. V for vector, S for scalar. Now if a vector is multiplied with another vector and the result is a scalar, okay, that is interesting. Two vectors multiplied to give the result as scalar, that is called dot product, represented by dot. Okay, example is work done, which is the dot product of force and displacement. Force, displacement, both are vectors, they are multiplied and the result is a scalar quantity. Now if two vectors are multiplied and the result is a third vector, then that kind of vector multiplication is called cross product, and it is denoted by a symbol cross in between. Example of such a product is like torque, where radius vector and force vector is multiplied to give the result of the torque vector. Okay, so these are the three kinds of multiplication that are associated with vectors. So with that, the differences between scalars and vectors comes to end.